Among the terrestrial plains, a massive geological wonder stands about 84 meters tall in the sky. This living giant holds the record for being the world's largest tree. The mighty sequoia, affectionately known as General Sherman, has carefully trapped about 1,400 tons of atmospheric carbon over its lifespan of nearly 2,500 years on Earth. In terms of carbon impact, few other trees can compete. While General Sherman's accomplishment is significant, humanity, on the other hand, produces over 1,400 tons of carbon dioxide each minute. Climate change is one of the most serious consequences of this carbon overproduction. To address this serious global issue, we must move fast to drastically decrease fossil fuel emissions and recapture excess carbon dioxide. In order to restore the delicate balance of greenhouse gases in our atmosphere, trees play an important role in this grand endeavor, but how do they properly absorb carbon? The solution lies in photosynthesis, the fundamental mechanism through which all plants, including trees, absorb atmospheric carbon and undergo a chemical metamorphosis using solar energy. Water and carbon dioxide are transformed into life-sustaining oxygen and energy-storing carbohydrates by this complicated process. Trees, in an incredible display of natural wisdom, retain a considerable portion of this carbon, storing it in newly formed wood tissue. Throughout their lifetimes, trees serve as tremendous carbon vaults, pulling down carbon for as long as they grow. Unfortunately, when a tree decays, a portion of its stored carbon is released back into the atmosphere. The carbon journey does not finish there. A large amount of carbon dioxide settles into the soil, where it might be trapped for millennia. The passage of time, on the other hand, causes even resting carbon to eventually leak back into the atmosphere, so continuing the complex cycle. Trees must survive and continue to store carbon for a long period of time, while rapidly refilling their numbers in order to be effective allies in our fight against climate change. The challenge is, can we select a single tree species that meets these exact requirements? Unfortunately, no such solution exists. Forests are complex interconnected ecosystems that thrive on diversity, and no single species can dominate. As a result, the cultivation of native tree species that have already integrated into their respective ecosystems is the most sustainable way to reforestation. According to research, ecosystems with a natural diversity of trees have less resource competition and are more immune to the effects of climate change. Adopting this knowledge requires us to go beyond simply planting trees to offset carbon emissions. Instead, we must work to restore destroyed ecosystems and heal the wounds caused by cutting down trees and human development. Recent studies, such as the one headed by Zurich's Crowther Lab, show that roughly 1 billion hectares of additional forest, or approximately 1.2 trillion trees, could potentially be accommodated globally. The scientific community has been stunned by this discovery, which has triggered further investigation. According to new estimates, these regenerated ecosystems have the potential to trap anywhere from 100 to 200 billion tons of carbon, accounting for more than 1/6 of humanity's carbon emissions. However, the task at hand is far from simple. Ecosystems are complex multidimensional puzzles, and it is debatable whether human involvement is the best approach for restoration. In some circumstances, it may be best to let nature do its thing, allowing for natural regrowth and regeneration. Furthermore, due to the synthesis of natural biochemicals, large-scale reforestation operations may unintentionally cause unanticipated consequences, such as accelerated climate change. The challenges are serious, and successful restoration requires safeguarding against the relentless forces of nature and economics that have historically contributed to the degradation of these environments. Despite these massive complications, restoring depleted places holds the potential of crucial data and commitment in our worldwide fight against climate change. With smart efforts and prudent judgments, these modern arboreal protectors may yet have the ability to grow into an incredible carbon-capturing giants, preserving the fragile balance of our planet. Thanks for watching. Kindly follow or subscribe to support our work.